Hi everyone and welcome. My name is Mahmoud Matouk. I'm a solutions architect with AWS Identity. I work with customers to help them build and design solutions for different identity use cases, and a big part of this is usually discussing best practices. In this session, I would like to discuss with you some of the best practices for web and mobile applications that use Amazon Cognito. What to expect in this session is a 300 level talk, so it will be slightly deeper, and I assume that you have existing knowledge in the service and some of the standards that we will talk about here. We will start by taking a look at how applications generally use Amazon Cognito, and then we will look at how to make this more secure. I'm going to share with you some best practices in 3 different areas. And since we have some limited time here, so I'm going to share with you a lot of offline read materials to expand on these concepts and these topics when possible. I'll always share this with a QR code, so you might be ready to take a screenshot if you need to. And if you are new to Amazon Cognito or you are looking for a refresher, I recommend looking at this session first. Scan this QR code. It's going to build a lot of groundwork for what we are going to say here in this session. So I recommend looking at this session first and then coming back here for best practices. All right, let's start by looking at how applications use Amazon Cognito. Let's say you have a web or mobile application that represents your business, and you have a set of back-end services. Could be microservices running on AWS behind API gateway or custom APIs. Could be a back-end running outside of AWS on premises, or it could be a back-end that is represented by AWS resources. So think about S3 buckets, Lambda functions, Dynamo tables, and you want the application client to be able to access these back-end services securely. So you have 2 Amazon Cognito services. We have Amazon Cognito user pool at the top. This is the user directory that allows users to sign in and sign up. And we have Amazon Cognito identity pool at the bottom, and this is a credentials broker service that allows your application to get temporary credentials to access these AWS resources, the green backend down there. The way that this usually works is that end users come into your application. You ask the user to authenticate or sign up. You can do this directly with the user pool using what we call a native user. So the user will sign up and authenticate using a username and password. Or you can federate this process to an external identity provider. Could be a social provider like Facebook, Google, Amazon, or most recently we added sign-in with Apple. Or it could be a standard enterprise IDP using SAML or OpenID Connect. In all cases, at the end of a successful authentication, Cognito user pool is going to issue standard JSON web tokens to your client app. The application can use these tokens directly to display user attributes or user data at the front end. And application can also use the token to authorize access to the microservices, the back end. If you are using a service like API Gateway, for example, then you can just attach the token to the authorization header. If you have a custom backend, then using the same method, you can pass the token to the backend and verify the token and use it for authorization. If the client app needs access to AWS resources, think about you need users to upload files to S3 bucket, or you need to send analytics data to some analytics service. In this case, the application will take a valid ID token for the user, the token that you got at step 4, and go to a Cognito identity pool and ask for temporary credentials. Based on the configuration in the identity pool, it's going to assume an IAM role and going to return set of credentials to your app based on the permissions associated with this IAM role. The credentials returned are in the form of an access key ID and a secret and a session token, and these are the form of credentials you need to use with the AWS SDK. So once your application gets a hold of these credentials, you can use them with the SDK. You can allow end users right from the client to access a wide range of AWS resources. So this is like the 10,000-foot view of how applications use Amazon Cognito. And again, I encourage you to scan this QR code, read more about this, and also look at the session that I recommended at the beginning of this session. So with that in mind, I would like to share with you some best practices in 3 different areas. First, how to step up your authentication game and provide better authentication and more secure authentication to your app and your end users. How to protect and monitor identity stack, and some best practices on secure handling of JSON web tokens. Let's take these one by one. First one, stepping up your authentication game. You can authenticate users with Amazon Cognito in different ways, and depends on the approach you take, the set of best practices might be slightly different. You can authenticate users using the hosted UI, and this is usually the path you take if you would like to use OAuth 2 or you would like to use the user pool as an OpenID provider, or in case of federation. All of these use cases go through the hosted UI. So if this is the path you take or the approach you take for your application, the best practice is to use authorization code flow. And it's also recommended to use Pixie, your proof key for code exchange, especially if you are building a single page application. If this sounds unfamiliar to you, I recommend looking at the blog post down there. It's going to expand on these concepts, and it's going to give you a hands-on tutorial of how to build this. The other best practices are to disable the unwanted flows. So if you are using authorization code, disable the implicit flow, disable the client credentials, and just enable the one that you are using. And a gold standard, whenever possible, enable multi-factor authentication. The second approach, and actually all of the other approaches, are using the APIs to interact with Cognito directly, but in different ways. The second one is using standard authentication. And what I mean by that is that it's using the AWS amplifier, using the low-level identity SDK, and building your own UI and interacting with Cognito as a user directory just using the APIs. You do this if you want to fully customize the UI or you have customizations that's needed for your application. And the recommendation in this approach is to use secure remote password protocol. SRP allows the backend to verify the password without actually transferring the password over the wire. So what's transferred is a means of a verifier. So this is the most secure way to do the authentication. In some cases, you might not be able to use SRP, like if you are doing a migration and using the migration Lambda trigger, you have to use user password in this case, user password role. But once this migration phase is done, it is recommended to fall back into the SRP as well because this is more secure. The other best practices in this approach is to enable device tracking. I'll expand on device tracking in a minute. And still disable unwanted authentication flows. So you have a user SRP, you have a user password, you have admin authentication, you have custom authentication. So decide which one you use and which one you need for your application and disable the others. The third approach is still using the APIs, but it's implemented as a custom authentication. And what this allows you to do is to take control of the authentication process. You can authenticate the user based on a set of one or more challenge and response cycles between Cognito and the end user. This flow is driven by Lambda triggers. It's driven by the define auth challenge, create auth challenge, and verify auth challenge. And it allows you to create passwordless authentication or authenticating the user based on custom factors like sending a magic link to email or using a security key or something like this. So if this is the approach you take for your application, the best practice is to pick up some strong authentication factors. Think about modern technologies like web authentication that allows you to use FIDO keys, Touch ID, Face ID, things that are more usable to the end user, and they are also highly secured. And the last approach is using admin authentication. Admin authentication is when you would like to build your own identity microservice and you just want to integrate with Cognito using the admin APIs. In addition to all of the other best practices, it is recommended now to use a client secret because this is considered a private client that you can protect the secret in your backend. The other flows are actually public clients, so you are not recommended to create a secret for these application clients. But if you are doing admin-only authentication, then generate a secret for the app client and use this secret from your backend. I'd also encourage you to take a look at the OWASP authentication cheat sheet. It's going to give you lots of other best practices. All right, before we leave the topic of authentication, let's talk about device tracking. How device tracking works is that when the end user authenticates with Amazon Cognito from a client using the SDK, Cognito is going to generate a device key and return this to the device. The SDK then is going to generate a secret or a password for this device, and it's going to confirm device with Amazon Cognito. Now, every time the user tries to refresh a token from this device, the device is going to be authenticated as well using SRP. The benefit you get from device tracking is that refresh tokens are tied to device key and cannot be used outside of this device. This is a huge security benefit for long-lived refresh tokens. It also can be always on or opt-in, and it is handled automatically by the SDK, so very minimal effort to get it done, and it adds lots of security benefit to long-lived refresh tokens. All right, moving on to the second topic, protect and monitor identity resources. If users cannot sign up and sign into your application, they will not be able to use your business. So it's important to make sure that this front door is always open and welcoming to your users. And this has two parts to it, or two phases to it. The first one is protecting these identity stack or identity resources from accidental deletion or human errors. And yes, I have seen many cases where an entire user pool got deleted by mistake, or an application client deleted and causing major disruption to a production app. The second part to this is making sure that these resources have enough capacity to handle expected volume. Cognito rate limits APIs, so you have to make sure that you are aware of these limits, and your utilization or usage against these limits is according to what you planned for. So let's take it an inch deeper in each one of these. Protecting resources from accidental deletion will always come down to limiting access or controlling who has access to these resources. And for that, I have two thoughts or two best practices to share with you. First, try to use automation to create resources. This might be a universal best practice. And the benefit of using automation is that you can assign permissions to tools and services rather than people. Tools and services are more predictable, can be tested, less subject to human errors. The second best practice, and I cannot stress enough on this one, is having a service control policy to protect production resources. If you are using organizations, you can put a service control policy on your production org or production account and deny deletion on all of these production resources. A policy like this could save you downtime. All right, the second phase to availability is making sure that you have enough capacity to serve your expected volume of users coming into your application. And the first part of this is visibility. And for that, I'm glad to say that Cognito finished integration with service quotas. And now you can go to service quotas, you can view the available limits, your utilization and usage against these limits, and you can request limit increase from there. So it provides you all of the information you need about your rate limits. And this is grouped by API categories. Cognito has different categories like user creation, user authentication, user list, user read. You can go and view all of these categories, view your assigned quota or assigned limits, and compare your utilization against these limits. My call to action here is that go ahead and review these categories that you are frequently using in your application, probably user creation and user authentication at least. Make sure that you create a couple of alarms on each category for different thresholds. You can create multiple alarms at 50% and up. Make sure that these alarms don't go unnoticed. If you are approaching the limit for a certain category, then probably you need to take an action. And this action could be simply you are organically growing and you need more limits, or it could be that there is a room for optimization in your app if you are making unnecessary API calls or repeated API calls, or if you have a high velocity attributes that are changing very frequently, then probably optimization there is needed. All right, the third topic is secure handling of JSON Web Tokens. At the end of a successful authentication, as we saw at the first flow, your application or the client app gets a set of tokens. These tokens are used as a form of authorization. They are used on the front end. They are used to get credentials to access AWS resources. So it is fair to say that the security of your application depends with a high degree on the security of these tokens. And for that, I'd like to share with you just a couple of best practices. This is just what I can fit in this short talk. The first one is controlling token content, verifying tokens properly before trusting them, and we will discuss secure storage of tokens. First, controlling tokens content, scope, validity, and purpose. What does this mean? Tokens that's created by Cognito are signed, they are not encrypted, and as they are not encrypted, it is best practice not to include sensitive data in these tokens. So I'm talking about payment information, highly sensitive BII or PHI data. This data, if existed in your application, it is not part of the user profile. So the best practice is always for this data to be locked down in a dedicated storage with network level permissions and application level permissions, and it's not being part of user profile or the ID token that's generated by Cognito. If you need to include some data in the token, then I recommend to suppress or tokenize this data. For example, you can use the pre-token generation trigger to load data from your backend, put this an object, put the object in cache, and then put the cache key in the token. So still the token is self-contained, it has some reference to the data, but the only component or the only module that has access to this actual data is your backend that has access to the cache layer. The second best practice here is to control the purpose of the tokens. And what do I mean by that? Is that tokens are issued for a particular audience, which is represented by the application client. Things that you can configure on the application client level are like the scoops that this application client has access to, the different read and write permissions on the user attributes, the token timeout. So these configurations decide a lot of scope about this token. If you have multiple applications, then use multiple application clients. Even in a single application, if you have different areas that has different security requirements, then it is recommended to use different application clients for these areas. As I mentioned, on the application client level, you can now customize the token timeout for each application client and for each token individually. So this gives you the ability to customize ID and access token between 5 minutes and 24 hours, and you can customize refresh token between 1 hour and 10 years, giving you wide range of use cases that you can satisfy. But to be able to use this, you might need to implement multiple application clients to represent different areas or different parts of your system. The second best practice is on token verification. If you are using tokens with a service that integrates automatically with Amazon Cognito, like API Gateway or Application Load Balancer, then these services are going to verify the token on your behalf. But at any given time when the token lands in your code and you need to make some decisions based on the content of this token, then you need to verify the token. And verification means mainly verifying that the token is authentic, it hasn't expired, and it is issued for the purpose of this application. Verification usually is done using some crypto library. There are many libraries out there. So the best practice, the first best practice here is to choose the library from a trusted source. JSON Web Token is just one of the libraries available. There are many libraries. I worked with many customers that build in-home or homegrown libraries for verifying JWT. So you can do this, but whatever library you choose, make sure that this is from a trusted source, it is tested, and you have the means of following up with any known risks in these libraries and applying regular patches to them. The second best practice here is to load the public key from the JWKS endpoint. To verify a token, the token is signed with a private key, and to verify the token, you need the public key. The public key can be accessed using this endpoint as formatted here. The first time you access the public key, you should load it from the endpoint. You can then cache the key on your backend. You don't need to load it every time. And the response of this endpoint is usually 2 keys. One key is used for access token, another key is used for ID token. Part of the response is also the algorithm that is used for signing, and this is important in the next best practice. The next best practice is when you verify a token, you have to feed in the algorithm. So don't let the verification process just read the algorithm from the token itself. Always treat the token as untrusted until verified. So you wouldn't take information from the token about how to verify the token. So this data has to be coming from a trusted backend. It could be even hard-coded in your application if you wish to, but it could be optimally coming from the JWKS endpoint as well. And finally, as you verify the token, make sure that you verify the issuer and the audience of the token as well. This will verify that the token is valid, it's authentic, it hasn't expired, and it is issued for the application client and from the issuer that you expect for this part of your system. This is particularly important if you have multiple application clients. All right, handling tokens when secured at the client side. Tokens are generated to your application client. Some tokens are long-lived. As you saw, refresh tokens can be living for years. So this brings the question that how should I store tokens on the client side, and is it even safe to store tokens on the client side? And this is one of the most debated questions. It doesn't have universally right answer. So let's take a look at the options and the trade-offs. Storing tokens at the client side, the first option for web applications is to use web storage or local storage. Local storage is accessible to your web app. It's convenient. It enforces the same origin policy. That's good. However, it is subject to cross-site scripting risks. What does this mean is that a web application that accepts input from a user and allows this input to show up for other users when they visit the website. Think about a product review. If an application accepts product review and allows every visitor to this product page to view this review, and an attacker was able to inject a script in their review, then this is potentially going to run for every user that visits the page, and it could potentially access data in the browser and send this data out to the attacker. So this is the risk with local storage. But if you think about this, this is not just related to token storage or related directly to the media that's used here, which is local store. It is a web application vulnerability. So this injected script can invoke methods or actions in your application. And if it can do so, it can reach the token wherever it is stored. So it is not necessarily a matter of the storage medium. This is a risk that needs to be mitigated anyway, right? So let's look at the other option. The other option is using HTTP-only cookies. And as the name indicates here, these are cookies that are HTTP only. They are not accessible via scripting. So that makes them immune to cross-site scripting. However, beside limitations in size and the fact that you need a backend to be able to set these cookies, they are subject to cross-site request forgery risks. And CSRF happens when an attacker uses an existing or established trust between the browser and a protected backend to trick the user into taking actions to benefit the attacker. Think about a malicious website with a click here to claim your rewards. And when the user clicks here, then the malicious website is going to send a request to change user password on the protected backend. Because this request is coming from the user browser and it's going to the right domain, the browser is going to attach the token to the domain to this request. And if the backend doesn't have any CSRF protection, the call may actually succeed. So once again, this is the problem with HTTP-only cookies. However, same argument, it is just a web application vulnerability that needs to be handled anyway, regardless of whether you're storing tokens or not. There are a range of other options, starting from using more volatile storage like session store or in-memory storage, all the way to storing tokens on the back end in a dedicated server. And all of these options have their own risks and their own problems. So it looks like all of the options have risks associated with them. So what is the real answer? What is the answer of where should I store tokens on the client side? And the answer is that there is no bulletproof storage medium that you can use on the client side. It will always come down to threat modeling of your application, understanding the risks, and putting mitigations in place, and then thinking from risk evaluation and risk tolerance perspective, what kind of risks you are willing to accept, and whether you put the mitigations in place to allow you to accept this risk or not. The decision is not purely technical. This is, again, a risk assessment decision, not necessarily a technical decision. So what are some of the best practices or the actions that I can share with you to start this mitigation process? First, if you are not already, think about using a web application firewall. Most of the modern WAF products have native rules to block these common web risks, and just by turning on these rules, you will get a great deal of protection to your app and your backend. Treat all inputs coming into your application as untrusted. Follow the best practices to sanitize, validate this data before letting it go anywhere in your app. Use libraries from trusted sources. Your application at the end might be like 40% code that you write, but 60% third-party libraries. So you need to make sure that these libraries don't have any vulnerabilities or any risks in them. Utilize frameworks native CSRF and XSS protection. Most of the modern frameworks, again, have some security features here and there, or security plugins that you can use to allow your application to protect itself from these common risks. And finally, enable device tracking. As I mentioned, this will protect or add additional protection to your long-lived refresh tokens. Refresh tokens will not be valid outside of this device. And you might also opt in to use shorter-lived tokens. So you can customize the ID and access tokens to a shorter lifetime. You can customize the refresh token to a shorter lifetime, and this is going to reduce the attack vector for these tokens. I'd recommend also taking a look at all of these offline reads to expand on the mitigations you can put in place. And I would like to leave you with that. Storing tokens on the client side is not a purely technical decision. There is no bulletproof solution to store tokens on the client side. It always comes down to risk assessment and risk tolerance. Depends on your risk profile and the domain you are in, and what mitigations you put in place to mitigate these attacks or these risks on your application. All right, so we talked about lots of things and almost at the end of the session. So let's quickly summarize what we talked about here. to have a secure web and mobile application, evaluate the end-to-end solution and make sure that you have threat modeling and you put mitigations in place. Step up your authentication game based on the approach you choose for your application. Make sure that you follow the best practices for this approach. Protect critical resources with service control policies. Cannot stress enough on this one. It's going to save your production resources. Monitor utilization, create alarms, make sure that these alarms don't go unnoticed. Optimize your API calls if you see that you are approaching the rate limits for a certain category. Make sure that you optimize your application or see what else you can do there to make this layer always available and welcoming to your users. Implement tokens best practices, as we said, control the token content, verify tokens before trusting them, and put mitigations in place if you store tokens on the client side, and implement risk mitigations according to your risk profile and your risk tolerance. All right, this is the end of my session. Thanks for watching and have a good day.